83b is asking us to do the same thing, but now we don't have equivalent dissolution. We have one side, calcium phosphate, breaks up into a total of 5 particles, ions, and iron phosphate just breaks up into 2. So, following the same method, KSP for this will be equal to concentration of calcium cubed times the concentration of phosphate squared. We can tell from the way it breaks up that the ratio of these are going to be 3 to 2, but remember, when we solve for x, we're always solving for the same thing. We're solving for the amount of the solid that will dissolve. So for every one of these that dissolves, we will get 3 of these. So KSP is going to equal 3x cubed times 2x squared. This turns into 108x to the 5th. If you want to go through and do it step by step, this turns into 27x cubed, this turns into 4x squared, 27 times 4 is 108, and x cubed times x squared is x to the 5th. So our KSP is 1.3 times 10 to the minus 32, and our x will just be our KSP divided by 108, the 5th root of that whole thing will equal x. So x is 1.6 times 10 to the minus 7. For iron phosphate, the KSP will be equal to the concentration of iron ions, the ferric, times the concentration of phosphate ions. No powers at all. So 1.0 times 10 to the minus 22 will equal x times x, or x squared. So if I take the square root of the KSP, I find x, and I find that x equals 1 times 10 to the minus 11. So, direct comparison, this is a larger number than this. Calcium phosphate has a greater solubility than ferric phosphate. Notice that when we started, the KSP for calcium phosphate was a smaller number. But because of the extra ions and the interaction, more of it will dissolve in water than iron phosphate will dissolve.